So good morning to everyone. Okay. Minute. Fine. So good morning. So what I will do is, before going to today's concept, I will briefly tell about yesterday's one. We'll discuss about yesterday's one, what and all we have discussed. Right? Now, when it comes to first point, with respect to yesterday's class, where we have discussed about concept 3.1, that is history. Right? That is why classification is required. So that's what it will be given in your textbook. Why classification is required. And we came to know that it is required because as there is a large number of elements have been discovered, so it will be difficult if you don't properly arrange them. Right? So that's where we have the first one. Why we have to classify the elements. Right? So next 3.2, that's where we have discussed about history. So when it comes to history, right, who and all who has contributed, where it has been done, so that's what we have discussed. Now when it comes to history, first one is Doberiner. We have discussed about Doberiner, where he talks about law of triads or triads, law of triads, right? So that's what we have discussed. What is law of triads? Law of triads tells that when he arranged, Doberiner arranged in a group of three elements, he found that first and third element, average of these two elements will be the atomic mass of the middle element, atomic weight of the middle element. That's what law of triads talks about. Please remember, it is related to atomic weight, nothing related to physical and chemical properties. Please remember. Fine. So once this is done, then we have discussed about Newland's theory. Right? So that is law of octaves. So we have discussed about law of octaves. So what is that law of octaves? So when he arranged the element, he found that first and the eighth element will have the similarities in their properties. That's where Doberiner atomic weight, here based on the atomic weight only he has arranged, but he is now talking about the properties. Right? So first and eighth element will have the similar properties. Fine. So that's where law of octaves. Then comes the Mendeleev's concept. Then comes the Mendeleev's concept. Now, what is that Mendeleev's concept? Who is the father of periodic table, right? So that's where he arranged the element based on the atomic weight. So based on the atomic weight, he arranged the element, right? So that's where we have the Mendeleev. He arranged the element based on atomic weight, with increasing the atomic weight. And to his surprise, he found that there will be similarity in the properties. Whichever element will come near to each other, they will have the similar properties. So that's where we have the Mendeleev, who arranged the element based on the atomic weight. So which we will call it as Mendeleev's periodic table. So we will call it as Mendeleev's periodic table. Right? So he was so accurate in his study that whatever space he left over, because that time some of the elements were not discovered or many of the elements were not discovered. For example, he kept a space below aluminium which he called it as eka aluminium. Same way he kept the space below silicon, which he called it as eka silicon. Right? And he guessed this should be the molecular weight of these elements. This type of compound with oxygen they should form. These should be the type of oxides they are going to form, and which was very, very accurate, because now we know that here it is gallium and here it is germanium. Now we know whatever he has predicted, that was accurate, because now we know the properties of gallium and germanium. They are well studied elements. Fine. So that's what we have discussed. Now when it comes to periodic law, that is Mendeleev's periodic law. What Mendeleev's periodic law talks about? It tells that periodicity in the properties of the element. Periodicity with respect to properties of the element. That can be chemical properties or it can be physical properties. So that's where we have the periodicities with respect to chemical or physical properties of the element will be related to atomic weight. That's where Mendeleev's periodic law talks about. What it tells? Physical and chemical properties of the element will be related to atomic weight. That word is important, periodicity in the properties. Okay? So that's what Mendeleev's periodic law. Now, due to the Henry Moseley experiment, who performed the experiment, so what he did, he went with the experiment where he compared frequency of the X radiation or X rays and atomic number. He found, or he got a linear curve. When he plot the graph, y-axis is square root of frequency of X radiation, and on the x-axis it will be atomic number. He found he had got a straight line. So based on that, he concluded that atomic weight is not going to decide the property, it is the atomic number. That's where first time people came to know the relation or importance of the atomic number. But otherwise, all this time, they used to think that atomic weight is very important, right? Which is going to decide the property of the element. But later, due to the Moseley's experiment, they came to know that it is not the atomic weight, it will be the atomic number which is going to decide the property of the element. Because same experiment, when he related with atomic weight, he didn't got the straight line. Same thing, Henry Moseley has done the experiment. He has plotted the graph with respect to atomic weight, but that time he didn't got the straight line. So based on that, he concluded that yes, there should be atomic number which is going to decide the property of the element. That's where comes the modern periodic law. That's where it comes into the picture. Right? Now what is that modern periodic law? So modern periodic law tells that periodicity in the properties of the element. Periodicity in the properties of the element will be related to atomic number of the elements, will be related to atomic number, atomic number of the elements, okay. So periodicity in the properties, that is properties of the element, will be related to its atomic number. Okay, it will be related to its atomic number. So that's where modern periodic law talks about. All of you have understood? Fine. So these were some of the important concepts which we have discussed in the last class. Now we are going to discuss about the features of periodic table, that is modern periodic table. So that's what we are going to discuss now. We are going to discuss about the properties or features of the modern periodic table. So that is, I am going to cover the 3.3 and 3.4. I am going to cover the 3.3 and 3.4. Now, one thing I will make it very clear. When it comes to periodic table, it's better, or my suggestion here is, you can go with the at least atomic number up to 35 elements. That will be better. If you have 35 elements, up to 35 elements, if you are able to arrange in the periodic table, then it will be enough for time being, for you people to understand. Because in some of the case, they will not give the atomic number, they will give the element. But without knowing the atomic number, you cannot solve that particular question. You cannot answer that particular question. So therefore, up to 35 element, if you know, you will be on the safer side, and it is a must. As a chemistry students, you should at least learn up to 35 elements. So before going for that, now, when it comes to modern periodic table, in the name itself it is there. Modern periodic table have been arranged based on increasing in the atomic number. If I want to talk about features of the modern periodic table, then I can tell that it is called as long form of, periodic table. First statement. Why it is called as long form of periodic table? That is because it is longer than that of the Mendeleev's periodic table, and there were lots and lots of spaces which have been kept for the inclusion of the new element whenever it will be discovered. That is the advantage of modern periodic table. Fine, no need to disturb the table. Straight away you can fill those gaps. So that was the intention. That's where we have the modern periodic table, which is also called as long form of periodic table. Now, second statement should be, here elements are arranged. Here elements are arranged with increasing order of, with increasing atomic number. Instead of telling increasing order of atomic number, you can straight away tell with increasing atomic number, not atomic weight. That is the difference between Mendeleev's periodic table and modern periodic table. Naturally, as the atomic number increases, atomic weight will also increase, but they were focusing on atomic number here, right? So here elements are arranged with increasing in the atomic number of the elements. All of you have understood? Now, next, when it comes to modern periodic table, it will be having periods, which we have discussed, periods and groups. It will be having periods and groups. Fine? So now, when it comes to periods, it is having almost 7 number of periods. It will be having 7 number of periods. When it comes to groups, it is having around 18 number of groups. It's having around 18 number of groups. All these things should be written when it comes to the features of periodic table. Fine? So that's where we have the periods of 7 numbers and groups of 18 numbers. Fine? And it is majorly based on modern periodic law. Periodic table is, our modern periodic table is based on modern periodic law. That's very important statement. Fine? So that's where we have the elements which are arranged in the periodic table. Now, with respect to the isotopes, So what are isotopes? In the name itself it is there. These are the elements which differs from each other with respect to their atomic weight. There is no change in the atomic number. They differs in their atomic weight. Right? So that's where next statement we should talk about isotopes. So which differs in the atomic weight. Okay. Or mass number. Why they differs in atomic weight? Yes? Why they differs? Yes, Gahan, you are right. So they have the same atomic number but differs in the atomic weight. But same atomic number. So why they differs in atomic weight? Naturally, due to the different number of neutrons. Due to the different number of neutrons. That's where they have the difference in atomic weight. Atomic number is same. That means number of protons should remain same. Number of proton is same. They do not differ in the number of protons, but they differ in the number of neutrons. So therefore atomic number will remain same, but mass number will vary. Right? Now, in modern periodic table, they have given the same position for the isotopes of the element. Why? Because they have the same atomic number. Because modern periodic table is based on the atomic number. That's what we have discussed, right? That is one of the feature of the modern periodic table. Since they are arranged based on the atomic number, they should occupy the same position. That's why the name iso, this word iso stands for same. Topos means related to position. Okay? So that's where isotopes are those elements which will occupy the same position in the periodic table. Right? So now, for example, if I take carbon, so we have carbon 12, carbon 30, carbon 40. Since they have same atomic number, we have omitted, we have not written the atomic number, or if you write the atomic number, no problem. All of them, they have the atomic number as 6. All these isotopes of carbon will have the same position in the periodic table, although they differ in their atomic weight. Right? So that's where we are going to give the average atomic mass, which you people have discussed in your basic concepts of chemistry. So they will be having average atomic mass will be given in the periodic table. It will not be exactly 12 when it comes to carbon. They will mention it as 12 point something. It will be in fractions. So that is because of the average atomic mass. And while calculating the average atomic mass, what they will do? They will even consider the abundance in the nature. Their abundance in the nature. See, for example, when it comes to carbon, carbon 12 is the one which is highly or abundantly present in the nature. Fine? All of you have understood? Any doubts? Okay? So these are some of the features of the modern periodic table. Still we have to discuss further. Okay? Still we have to discuss. But all of you have understood? Any doubts up to here? 3.3, 3.4 in textbook. Those concepts we have discussed. Okay? Now, further if you want to have the discussion, then we have to talk about with respect to periods and groups. Now, I will make it very clear that to understand the periodic table or classification of elements, first and very important point here is you should be very thorough with your atomic structure topic. Then only you can appreciate this particular topic because they are related to each other. Now, if you go back, when it comes to atomic structure, that's where we have discussed about the subshells, right? So that's where we have discussed about the subshells. Now, at energy level 1, when n is equal to 1, we have the subshell S. When n is equal to 2, we have the subshell as S and P. When n is equal to 3, we have subshell SPD. Right? So when n is equal to 4, we have SPDF. So these are the subshells which are available at respective energy level. What is n? Principal quantum number. So that's where when n is equal to 1, we have the S subshell, which is the only subshell which is available. Now when it comes to n is equal to 2, that is where availability of S and P. When it comes to n is equal to 3, that's where the availability of SPD. And when it comes to n is equal to 4, then that's where the availability of SPDF. All of you have understood? Fine? Now, along with that, even you should be knowing Aufbau diagram. You should be knowing Aufbau diagram. 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F, 5S, 5P, 5D, 5F, 6S, 6P, 6D, 6F, and last we'll go stop here, 7S, 7P, 7D, 7F. Okay, I'm talking about Aufbau diagram. What is Aufbau diagram? Aufbau is nothing but meaning is to build up. It's not a person name. Aufbau is not the person name. The meaning of Aufbau is it is related to something we are going to construct. Fine. So that's where we have the 1S which will be occupied. Then comes the 2S. Then comes the 2P and 3S. Then comes the 3P, 4S. Then comes 3D, 4P, 5S. Then comes 4D, 5P and 6S. Then 4F, 5D, 6P and 7S. 5F, 6D, 7P. Like that it will be arranged. Electrons will be occupying. That means first 1S will be filled. Then comes the 2S. Once 2S is filled, then comes the 2P, then 3S, then 3P, then 4S. If you observe it carefully, before going for 3D, 4S is going to get filled up. So once 4S is filled, 3D will come, 4P will come, 5S. So 5S will be filled first before 4D. Now 6S will be filled up before 4F. So that's where we can find F subshell will come into the picture. Observe it carefully. F subshell will come into the picture only at energy level 6. Although there is the availability of the F subshell even at energy level 4. Try to understand this. But still, F subshell will not accommodate the electron until energy level 6. 6S is not getting filled up. All of you are understanding? That is the importance of the Aufbau diagram. Right? So what I mean to tell here is, observe here carefully, there is where n is equal to 4, where SPDF subshells are available. But even now, F subshell will not be occupied here. Right? So therefore, only when we are talking about the element where we have electrons which will go up to 6s, then only 4f will come into the picture. The relation between F and energy level is n minus 2. The relation between outermost energy level and F subshell is n minus 2. So when outermost energy level is 6, then 6 minus 2, then comes the 4f, then comes the 4f. Same if you observe it carefully, 3D, D subshell is available at energy level 3 itself. D subshell is available at energy level 3 itself, but it will not be accommodated until unless 4S is getting filled up. Until unless 4s is getting filled up. So once 4s is getting filled up, then only 3d will come. All of you are understanding? So that's where we have the relation outermost energy level and d is n minus 1d. N minus 1d. So what I mean to tell here is, if you are talking about element like sodium, what is the atomic number of sodium? 11. So when I am talking about sodium, now all of us we know that we are going to consider neon as the inert gas, right? So it will be 3s1. It will be 3s1. Now, if you increase the atomic number in period number 3 only, if you increase the atomic number, just like if you go to the next, magnesium, then aluminium, like that, if you go on increasing the atomic number, nowhere we are going to get the d subshell. Nowhere d subshell is going to get filled, because still we are in the energy level 3. Fine, okay, anyway, I will come to that point, but all of you have understood n minus 2f and n minus 1d. Why I have written? Any doubt? You should understand this one, because based on that we should write the general electronic configuration for d block elements, f block elements, p block element and s block element. All of you have understood why n minus 2 and n minus 1 for f and d subshell respectively? All of you have understood? Any doubts? If you have any doubts, you can raise the question. Okay? Otherwise, I will move to the next concept. Let it be there only. We will not going to disturb those diagrams. We will not going to disturb that one. Now, I will write some of the elements. Okay? So, I will still not sure, sir. Okay, someone has written. Still not sure. Okay. So, I will explain it once again. No need to worry. So, now, first and very important thing here is, whenever we are talking about periodic table, you should be understanding about these features which you people have studied in your atomic structure. According to that particular concept, we know that for energy level 1, S subshell is available, like that SP, SPD and SPDF. Like that it will go on. As we increase the energy level, availability of the subshell is going to increase, right? But we are going to talk about SPDF only. Fine? Now, this is Aufbau diagram. That's where electrons will be occupying. That's where electron will be getting filled up, right? So, always remember that Aufbau diagram is nothing but energy level diagram. And always, please remember that in the nature, energy will be from lower energy, it will go to the higher energy, right? Same logic is applicable. 1s will be of lower energy compared to 2s, which will be lower energy compared to 2p. Then 3s will be of lower energy compared to 3p. Like that, it's going to be arranged, right? Now, when I am talking about 4s, if you observe the Aufbau diagram, 4s will be of lower energy compared to 3d. 4s is of lower energy compared to 3d. I am not talking about hydrogen, I am talking about multi-electron containing species, right? So that's where 4s will be of lower energy compared to 3d. Why I am telling this one? Because once 4s is 4s2, when 2 electrons are occupying the 4s orbital, then comes the 3d. Then only 3d orbital is going to get filled up. So what I mean to tell here is, if I am talking about an element where in that element outermost energy level is 3, in that element outermost energy level is 3, still they will not be having any electron in their d subshell. It will be empty. It will be empty. Got my point? So still, although they are having outermost energy level as 3, although there is availability of d subshell, it will not be filled. That is because until we have the electron which is going to occupy the 4s, then only 3D will be occupied. That's what of Bohr diagram talks about, and which is absolutely correct. Now all of you have got point. So based on that, we can write it as n minus 1d. N minus 1d. That means when I am talking about energy level 4, 3d subshell is going to get filled up. If I am dealing with the d subshell, if I am talking about the d subshell, whenever energy level 4 is there, that time 3d is going to get filled up, not 4d. Now, whenever I am talking about energy level 5, then comes 4d which will get filled up. Then comes the 4d which is getting filled up. So 5 minus 1 is 4. So 4 minus 1 is 3. So based on that, we can generally tell that n minus 1 d subshell is going to get filled up. All of you have understood? Now same logic for F. If you observe the F, at energy level 4 itself, F subshell is available, but they are not going to get filled up. Until unless we are having an element which is having energy level 6 as its outermost one, then only 4F is going to start getting filled up. Energy level 6, then only 4F is going to start getting filled up. Right? Same logic. If I am talking about 7s, then only 5F is going to get filled up. Right? So therefore, an element which is having energy level 6 and 7, only in those elements F subshell is getting filled up. So if you understand this one, then you can easily understand the whole periodic table concept. Fine? So therefore, I have written n minus 2F and n minus 1D. Fine? All of you have understood? Now, in detail, I will talk about the periods and groups. Okay, in detail I will talk about the periods and groups. Now, if I take the element, I have hydrogen as the first element, right? Anyway, in your NCERT textbook, hydrogen they have given a separate position. Why? I am going to tell that one, and anyway, these concepts you are going to discuss in your hydrogen topic also. You are going to discuss in your hydrogen topic also. So that's where I have the hydrogen. Somewhere here I will mention helium. So that's where I will consider this one as period 1. Okay, this is nothing but period 1. Now, when I am talking about period 1, we know that this is 1s1, so this is 1s2, right? So energy level 1 I am talking about. When I am talking about period 1, each period in the periodic table talks about energy level. Each period in the periodic table talks about energy level. So that means when I am talking about hydrogen and helium, I am filling the energy level 1, where only S subshell is available. Where only S subshell is available. So therefore, period 1 can accommodate 2 elements only, because S subshell can accommodate only 2 electrons. Whether I am clear? So that's where we have the hydrogen 1s1 and we have the helium 1s2. That's where energy level 1 is done. There is no question of extra element in the energy level 1. Okay, so Ashish, I will give the answer for that hydrogen. Why it will be placed with metals? But if you observe your NCERT textbook, it's placed on the top of the periodic table. Not with the metals also, not with the non-metals also. Give me another 5 to 10 minutes. I will explain it, why it has been placed like that. Fine? So, that's where we have hydrogen and helium. All of you have understood? So, now we will move to the period number 2. Now we will move to the period number 2. So now all of you know why only two elements. Why only two elements are present in period number 1? You got the answer. That is because we are filling the S subshell with respect to energy level 1. And only S subshell is available in energy level 1. Now we will come to period number 2. When it comes to period number 2, we have S and P. We have S and P. There is no question of S and P. We don't have N minus 1P, N minus 2P. No, it will be NP. NS, NP. Direct relation. Right? So therefore, when I am talking about period number 2, how many elements you expect in period number 2 in that case? How many elements you are going to expect? Any one of you? Yes, Ashish, very good. We are going to have the 8 elements because 2 electrons in S, 6 electrons in B. So total it will be 8 electrons. So we have to talk about those 8 electrons. All of you are correct. Yes, that's where we will be having 8 elements. Right? So now I have the lithium. Right? Then I have the beryllium. Then I have the beryllium. Anyway, I push this one bit that side. Now, lithium beryllium will move to here. That is boron, carbon, nitrogen, oxygen, fluorine, and neon. So I have to shift helium also. So I will shift helium. That's where I have the helium here. Right? So period 1, this is period 2. That means here it should be NS1, here it should be NS2, here it should be NS2, NP1. Right? Same way, NS2, NP2, NS2, NP3, NS2, NP4, then NS2, NP5. Then NS2 and P6. So here it is 1s2. All of you have understood? So to be more specific, I can straight away mention it as 2s1. So here also I can mention it as 2s2. So here also I can mention it as 2s2, 2p1. So 2s2, 2p2, like that, where n will be equal to 2. Right? Because we are dealing with the energy level 2. So period number 2, this 2 indicates the n value. Period number 2, that 2 indicates the n value. That means when I am talking about period number 1, this is the condition. Nucleus with element having 1 energy level. When I am talking about period number 2, I am dealing with the element with 1 nucleus, energy level 1 and energy level 2. All of you have understood? Now same way, if I go with the period number 3, that means I will be talking about energy level 1, energy level 2, energy level 3. Right? So I have to entering into energy level 3. Each period I am taking one step up. Right? So energy level 1, energy level 2, energy level 3. So I am taking one step up with respect to the energy level. Now when it comes to energy level 3, according to this diagram, how many electrons should be accommodated? According to this diagram, energy level 3, how many electrons should be accommodated? It should be 18. According to that diagram, all of you are absolutely correct. But when it comes to periodic table, you people are wrong. Right? So according to this particular diagram, all of you are absolutely correct. But in reality, in periodic table, you people are wrong. In period number 3 also we have only 8 elements. The reason is D subshell will not going to have any electron. D, n minus 1 D. Right? So period number 3, no D subshell is going to have the electron, because D subshell will have the electron only once the 4 as energy level we are dealing with. Please try to understand. Sri Vidya, why you have deleted the message? You were right. It should be 8. Period number 3. Once again, it should be 8 elements only, not 18. Try to understand this. Once again, I will explain. According to this diagram, I am not telling whoever has written 18, you people are not wrong. Because according to this diagram, I have asked the question. So according to this diagram, 2 plus 6, 8 plus 10, 18. Because D subshell can accommodate 10 electrons, P subshell can accommodate 6 electrons, and S subshell can accommodate maximum 2 electrons. So total 18 electrons. Absolutely fine. It's absolutely correct. But if you see the periodic table, in period number 3 also we have only 8 elements. For that, the answer is, when it comes to D subshell in energy level 3, there cannot be any electron which can be accommodated until unless energy level 4 is getting filled up in its S subshell. So therefore you can see here n-1D. We don't have 2D. So we have 3D. From 3 energy level 3 only, D subshell is available. Right? So when you are moving to the element with energy level 4, then only 3D will get filled up. So therefore, in period number 3 also, we should have the 8 elements only. All of you are clear? If any doubts are there, no need to worry, no need to hesitate. I am ready to explain it once again. But don't go with doubts. Fine? So all of you have understood? So it should be 8 elements. The reason is, at energy level 3, D subshell will not be filled up. Only when we are going to energy level 4, then only D subshell will start filling up. Fine? Since we are talking about maximum energy level 3, still we should have the 8 elements only. Fine? So that's where I will be having next element as sodium, then magnesium. Sodium and magnesium. Then I will directly jump over here. So boron, then we have the aluminium, then we have the silicon, then we have the phosphorus, then we have the sulfur, then we have the chlorine, then we have the argon. Right? So that's where we have the elements. Fine? Now, once again here also it will be NS1, NS2, then NS2, NP1, NS2, NP3, NS2, NP4, NS2, NP5, then NS2, NP6. Like that it will be arranged. NS2, NP1, so NS2, NP3, NP2 should have been NP2. Then NS2, NP3, NS2, NP4, NS2, NP5, NS2, NP6. Okay? So NS2, NP1 for aluminium. Since lack of place, try to understand. NS2, NP1 for aluminium, NS2, NP2 for silicon, NS2, NP3 for phosphorus, NS2, NP4 for sulfur, NS2, NP5 for chlorine, NS2, NP6 for argon. If you observe, right, this is where we can write. But one thing is clear, that here N should be equal to 3. Here N was equal to 2, here N should be equal to 3. All of you can see the board, whatever I have written, or it's difficult? If you people are feeling difficult, so what I will do is, whether all of you can see, because I have to write some more elements here. That's why I am asking. Fine? So whether it's visible, whatever I have written. So NS2, NP1 for boron, NS2, NP for aluminium, NS2, NP2 for carbon, NS2, NP2 for silicon, NS2, NP3 for nitrogen, NS2, NP3 for phosphorus, NH2NP4 oxygen, NH2NP4 for sulfur, NH2NP5 for fluorine, NH2NP5 for chlorine. Then comes the NH2NP6 for neon, NH2NP6 for argon. Okay? Only thing, it's visible, but only thing is the columns are like not in proper order. Okay? So fine. So that's where we have the period number 3. In period number 3, what is happening? Energy level 3 is getting filled up. Energy level 3 is getting filled up. Fine? All of you have understood? Now we will move to the energy level 4. That is period number 4. We are talking about period number 4. That's where 1, 2, 3, 4. So whenever I am talking about energy level 4, I will be dealing with total energy level. Maximum energy level will be 4. Outermost energy level will be 4. Fine. Now here it will be potassium and here it will be calcium. Right? So that's where we have the NS1. That's where we have the NS2. Where N will be equal to 4. That means we are talking about valence shell or outermost shell. Fine. Now, when it comes to period number 4, that means energy level 4 I am entering. At energy level 4, how many electrons? According to this diagram, how many electrons will be there in N is equal to 4? Don't focus on periodic table. Talk about this diagram. How many electrons? It should be 32. Very good. So that's where I have 2, 6, then 10, then 14. Right? So that's where I can have the 32 electrons. According to that, at period number 4 in periodic table, you should have got 32 elements. But that is not the reality. Why that is not the reality? Because F subshell is not going to get filled up. N minus 2F. N minus 2F. All of you are absolutely correct. According to this picture, yes, it should have been 32 electrons. That means at period number 4, it should have been 32 elements. But that is not the reality. Because according to Aufbau diagram, according to Aufbau principle, F subshell is not going to get filled up. Govardhan, absolutely correct. It will be 18 elements because S, P and this D. Okay, S, P, D is going to get filled up. So therefore 18 elements. Which are those? This S and this D is going to get filled up. Right? Not this D. Try to understand. I am not talking about this D subshell. I am talking about this D subshell, which is going to get filled up. 3D is going to get filled up. Therefore, D subshell 10, D subshell 6, S subshell 2. So total 18 electrons. So therefore, we should have the 18 elements. We should have the 18 elements. Now I have to accommodate here. Fine. So scandium, titanium, then vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Okay, I have tried to accommodate, but they are very close to each other. Sorry, pa. So whether it's visible, I have written scandium, titanium, vanadium, chromium, that is Cr, chromium, manganese, iron, cobalt, nickel, copper, zinc. Right? All of you have understood? Then I will come to this one, that is gallium, eka aluminium, right? So that is gallium. Now eka silicon, that is germanium. Now phosphorus, that is arsenic. Then sulfur, here it should be selenium. Then chlorine, here it should be bromine. Then krypton. After argon, it will be krypton. Fine. So don't focus on D subshell. I will explain. But we are not going to worry about the D subshell in first PU. We are going to discuss that one in your second PU. So no need to worry. But we will have the atomic numbers. We will have the discussion. Fine. So that's where we have the period number 4. That means I am talking about NS1, NS2. NS1, NS2. Then comes the P block elements. I am going to talk about that one. So NS2, NP1, NS2, NP2, NS2, NP3, NS2, NP4, NS2, NP5, NS2, NP6. So like that it will be present. But where n is equal to 4? Where n is equal to 4? So when I am talking about n is equal to 4, observe here, look at here, I am talking about energy level 4, right? So NS1, NS2, S subshell is getting filled up. NS1, NS2. So S subshell is got filled up, right? So that means 4S1, 4S2. S subshell is done. But after S subshell which is coming? 3D. That means in this case D subshell is getting filled up. In this case D subshell is getting filled up. In that case how many elements should be there? Total 10 elements should be there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So total 10 elements. All the D subshell will get filled up. When it comes to zinc, it will be N minus 1 D10. When it comes to zinc, N minus 1 D10. D subshell is filled. Now comes the P subshell which is going to get filled up. That is 4P. P subshell is going to get filled up. So 4S2, 4P1, 4S2, 4P2, 4S2, 4P3, 4S2, 4P4, 4S2, 4P5, 4S2, 4P6. Done. Got my point? All of you have understood? That's how there will be presence of the elements. Any doubts in this? All of you have understood? Like that we will be having period number 5, period number 6, period number 7. Total 7 periods are there. I have written up to period number 4 and I can see there will be presence of 2 elements, there will be presence of 8, there will be presence of 8, then comes the 18. What about period number 5? How many elements in period number 5? How many elements can be accommodated in period number 5? It will be 18 once again. Period number 5 also it will be 18 elements. We are moving to the next one. Right? It will be period number 5 also it will be 18. I have not written. Now what about period number 6? How many elements? Okay, fine. That is 18 for period number 5. So why at period number 5 we have the 18 elements? That is n is equal to 5. S, P, D, F, even G. Anyway, G is not going to discuss. S, P, D, F. Right? But when it comes to period number 5, there will be filling of 4D. There will be filling of 4D. When we talk about period number 5, we will be talking about N minus 1D. That is 4D. Right? So how many? It should be 18 once again. It should be 18, not 32. Shri Vidya, you are absolutely right. It should be 18. According to this diagram, yes, 32. No doubt. According to this diagram, 32. If you people have taken this diagram as the consideration, then yes, 32. But if you go to the periodic table, because of the FO principle, it will be 18. Why 18? Because D subshell is getting filled up. At energy level 5, we don't have filling of F subshell. Because F subshell will be N minus 2F. because 5 minus 2 is 3. At energy level 3, there is no F sub shell. Fine. So even at energy level 5, there is no question of F sub shell. Yes, Darshan, absolutely fine. Now when I am talking about period number 5 is done, 6, then it will become 32. Absolutely fine. Then it comes 32. Same logic, when it comes to period number 7, it will be 32. Fine, all of you have understood? So therefore, if I see the elements across the period, it will be 2, 8, 8, 18, 18, 32, 32. Okay, only once 2 will come, but rest of the things it will be repeated twice. Right? So 2, 8, 8, 18, 18, 32, 32. So why here 32? Because here n minus 2 F sub shells are also getting filled up. Yes, Shri Vidya, it will be 2, 8, 8, 18, 18, 32, 32. All of you have understood? Any doubts? Fine. So this is how we will be talking about the periods. This is how we are talking about the periods. Now if you observe the column, so this is column number 1, this is column number 2. Here I am talking about how many elements are there? Here 10. That means we have the 10 columns. So 3, 4, 5, 6, 7, 8, 9, 10 columns. Right? Now comes the 11th, 12th, 13th, 14th, 15th, 1, 2, 3, 4, 5, 6. One minute. So here 1, 2, 3, 4, 10, 18. So I have written properly now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18. Okay, there are total 18. Okay, there are total 18. Oh, this 11 and 12 should have been this side. Okay, this is 13, 14, 15, 16, 17, 18. So like that it will be present total 18 groups. Total 18 groups. Fine. So 1, 2, 3 to 12. It belongs to D block or transition element. 3 to 12. Up to these columns, they belongs to transition elements. 1 and 2, they belongs to one category. From 13 to 18, they belongs to another category. So what I mean to tell here is, when I am talking about 1 and 2, if I observe group 1, 1s1, 2s1, 3s1, 4s1. If I come to group 2, so 2s2, 3s2, 4s2. Right? So same way, if I come here, boron, ns2, np1, that is 2s2, 2p1, 3s2, 3p1, 4s2, 4p1. So what I am observing here is an element which belongs to same column. An element which belongs to same column. They have the similar outermost electronic configuration. They have the similar outermost electronic configuration. That's what I can conclude. Right? So if I see here 1s1, 2s1, 3s1, 4s1. So 2s2, 3s2, 4s2. Like that it's going on. Similar outermost electronic configuration. Same logic is applicable here also. They have the similar outermost electronic configuration. So what I mean to tell here is, elements which are occupying the same group will have the similar outermost electronic configuration. Due to that, you can complete the statement. You can fill the gap. I am telling that elements occupying the same group will be having similar outermost electronic configuration. So due to that, I am not talking about period. Please remember, when I am talking about the period, it is a horizontal row. It's a horizontal row. Now I am not talking about period. I am talking about the groups. So total how many groups we have? Columns we have 18. Groups are nothing but columns. Okay. Gahan is telling they lie in the same group. Fine. So elements which are present in the same group will have similar outermost electronic configuration. Due to that, they will have similarity in their properties. I am not talking same, I am telling similarity. They will be having similarity in their properties. So what I mean to tell here is, group 1, which are called as alkali metals, we are going to discuss this one in detail in S block elements. So lithium, sodium, potassium, like that, rubidium, cesium and all, they will be having similar properties. Same logic when it comes to group 2, alkaline earth metals. Same logic comes for all these groups, they will have similar properties. Why they will be having similar properties? Due to the similar outer electronic configuration. So therefore, groups are also called as families. Groups are also called as families. Why family? Because in a family, like father and mother, kids will be having similar characters. There will be some character which will be influenced by the friends. That is a different story. But in general, if I want to tell, in a house or in a home, in a family, like father and mother, there will be some of the character which will be coming to the kids also. So therefore, due to that reason, here also groups elements which belongs to the same group will be considered as one family. Not the period. I am making it very clear. I am not talking about the period. Elements present in a period, definitely they will not have the similar properties because they have different outermost electronic configuration. They don't have the similar outermost electronic configuration. All of you have understood? Any doubts? So still we have done with 3.1, 3.2, 3.3 and 3.4. Still we have not come to 3.5. Still we have to discuss a lot. But whether I am clear? So elements present in the same group will have the similar properties, especially chemical properties. And whichever belongs to in the same period, they don't have the similar properties. Fine. So therefore family, that name is given only to those elements which are present in the same group, not in the same period. Fine. In that case, I will stop here. We will continue in the next class. But any doubts? And don't worry about D and F block element at this moment, which you are going to discuss in detail in your second PUC. Okay. So this time we are going to focus on S and P block. Fine? Okay, in that case, I will stop here. Tomorrow we are going to continue this class. Thank you very much. Take care.